The risk category for working on electrical equipment not associated with switchboards, panels, or motor control centers is typically Category 2. The absence of these energy-limiting devices indicates that a potential arc flash hazard exists. According to NFPA 70E, the minimum required flame-resistant clothing for Category 2 arc flash risks is in hazard risk category of 2. This translates to a calculated arc flash rating of 8 calories per centimeter squared or less. An hazard risk category of 1, with an incident energy of less than 8 calories per centimeter squared, is permissible if an incident energy analysis has been performed and demonstrated to meet the arc flash hazard risk. In addition to flame-resistant clothing, additional arc flash personal protective equipment is required, including a face shield or helmet with a visor rated for the hazard risk category, arc flash gloves rated for the hazard risk category, safety glasses with side shields, and insulating rubber boots only if the floor is potentially energized. Working on energized electrical equipment requires shock hazard protection. The following should be used: insulating gloves rated for the maximum voltage present, insulating tools to prevent contact with live conductors, and a voltage rated mat to stand on when working near energized parts. Chiller control cabinets typically operate at lower voltages such as 120 volts and have limited short circuit currents. Therefore, the arc flash hazard may be reduced compared to switchboards or panels. However, a risk assessment should still be performed to determine the actual arc flash hazard and appropriate personal protective equipment requirements. This assessment should consider factors such as system voltage, system impedance, distance to energized components, and availability of short-circuit current limiting devices. If wearing the full personal protective equipment specified above is prohibitively cumbersome, the following measures may be considered. Firstly, use remote monitoring and troubleshooting techniques. Secondly, isolate the hazardous area and apply lockout-tagout procedures. Thirdly, use live line maintenance techniques which require specialized training and equipment. And fourthly, work during non-operating hours or when the equipment is de-energized. Note that all work should be performed in accordance with NFPA 70E and other applicable safety regulations. It's crucial to understand the specific hazards associated with electrical work, especially when dealing with equipment that doesn't have built-in energy-limiting devices. Category 2 is a common classification, but it's not a one-size-fits-all solution. A proper risk assessment is essential to determine the actual hazard level. Let's break down the personal protective equipment requirements a bit further. The flame-resistant clothing is designed to protect you from the thermal effects of an arc flash. The 8 calories per centimeter squared rating is a measure of the heat energy that the clothing can withstand. If an incident energy analysis shows that the potential arc flash is less than 8 calories per centimeter squared, then an hazard risk category 1 flame-resistant clothing may be sufficient. However, it's always better to err on the side of caution and use the higher rated clothing if there's any doubt. The face shield or helmet with a rated visor is critical for protecting your face and eyes from the intense heat and debris generated by an arc flash. Arc flash gloves are designed to protect your hands from electrical shock and burns. Make sure they are rated for the voltage you are working with. Safety glasses with side shields are important for protecting your eyes from flying debris. Insulating rubber boots are only necessary if the floor is potentially energized. This is more likely to be the case in wet or damp environments. Shock hazard protection is just as important as arc flash protection. Insulating gloves are designed to protect you from electrical shock. Make sure they are rated for the maximum voltage present in the equipment you are working on. Insulating tools are essential for preventing contact with live conductors. A voltage-rated mat can provide an additional layer of protection by isolating you from ground. When working on chiller control cabinets, it's important to remember that even though they may operate at low voltages, there is still a potential for arc flash and shock hazards. A thorough risk assessment is crucial for determining the appropriate personal protective equipment requirements. Consider factors such as system voltage, system impedance, distance to energized components, and the availability of short-circuit current limiting devices. If wearing the full personal protective equipment specified above is prohibitively cumbersome, there are several alternative measures that can be taken. Remote monitoring and troubleshooting techniques can allow you to diagnose problems without having to physically enter the hazardous area. Lockout-tagout procedures are essential for energizing equipment before working on it. Live line maintenance techniques require specialized training and equipment, but they can allow you to work on energized equipment safely. Working during non-operating hours or when the equipment is de-energized can also reduce the risk of arc flash and shock hazards. Remember, all work should be performed in accordance with NFPA 70E and other applicable safety regulations. Safety should always be the top priority. It is paramount to approach electrical work with meticulous planning and adherence to safety protocols. First, conduct a comprehensive job hazard analysis to identify potential risks associated with the specific task at hand. This analysis should encompass all aspects of the work, from preparation and execution to post-completion procedures. Second, verify that all personnel involved possess the requisite training and certifications for the electrical equipment and tasks involved. Regular refresher courses and ongoing education are essential to maintain proficiency and stay abreast of evolving safety standards. Third, ensure that all tools and equipment are in good working order and properly rated for the voltage and current levels encountered. Inspect tools before each use for any signs of damage or wear, and replace them promptly if necessary. Fourth, implement a robust lockout-tagout procedure to energize the electrical equipment before commencing any work. This procedure should involve disconnecting all power sources, verifying the absence of voltage, and applying locks and tags to prevent accidental re-energization. Fifth, utilize appropriate personal protective equipment, including flame-resistant clothing, arc flash-rated face shields, gloves, and footwear. The specific personal protective equipment requirements should be determined by the arc flash hazard assessment. 6. Maintain a safe working distance from energized electrical equipment. This distance, known as the approach boundary, is determined by the voltage level of the equipment and is intended to prevent accidental contact with live parts. 7th. Use insulated tools and equipment to prevent electrical shock. These tools are designed to provide a barrier between the worker and energized conductors. 8th, provide adequate lighting to ensure clear visibility of the work area. Proper lighting can help prevent accidental contact with energized equipment. 9th, establish clear communication protocols among all personnel involved in the work. This includes pre-job briefings, regular check-ins, and a designated point of contact for any safety concerns. 10th, continuously monitor the work environment for any changes or unexpected hazards. Be prepared to stop work if any unsafe conditions are encountered. In addition to these general safety practices, there are several specific considerations for working on electrical equipment not associated with switchboards, panels, or motor control centers. First, determine the arc flash hazard category for the equipment. This can be done by performing an arc flash hazard assessment, which takes into account the voltage, current, and clearing time of the electrical system. Second, select personal protective equipment that is appropriate for the arc flash hazard category. The personal protective equipment should be rated to protect against the potential thermal and blast effects of an arc flash. Third, be aware of the potential for shock hazards. Electrical equipment that is not associated with switchboards, panels, or motor control centers may not have the same level of insulation and protection as other types of electrical equipment. Fourth, use caution when working on energized electrical equipment. If possible, de-energize the equipment before commencing any work. Fifth, follow all applicable safety regulations and standards. These regulations and standards are designed to protect workers from electrical hazards. By following these safety practices, you can significantly reduce the risk of electrical injuries and fatalities. Remember, safety is always the top priority. No task is so important that it cannot be done safely. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical safety professional before commencing any electrical work. Furthermore, understanding the intricacies of arc flash incidents and their associated dangers is crucial for ensuring workplace safety. Arc flash is a phenomenon that occurs when an electrical fault creates a sudden release of electrical energy, resulting in an intense burst of heat, light, and pressure. This explosion can cause severe burns, blindness, hearing loss, and even death. The severity of an arc flash incident depends on several factors, including the voltage and current levels, the distance from the arc, and the duration of the exposure. Arc flash incidents can occur in a variety of electrical equipment, including switchboards, panel boards, motor control centers, and transformers. They can also occur in less obvious locations, such as control panels and junction boxes. To protect workers from the hazards of arc flash, it is essential to conduct an arc flash hazard assessment. This assessment involves identifying potential arc flash sources, calculating the incident energy levels, and determining the appropriate personal protective equipment requirements. The incident energy level is a measure of the amount of heat energy that a worker would be exposed to during an arc flash incident. It is typically expressed in calories per centimeter squared. The personal protective equipment requirements are based on the incident energy level. For example, if the incident energy level is 8 calories per centimeter squared, the worker would need to wear flame-resistant clothing, an arc flash-rated face shield, and arc flash-rated gloves. In addition to personal protective equipment, there are several other measures that can be taken to reduce the risk of arc flash incidents. These measures include energizing equipment before working on it, using insulated tools and equipment, and maintaining a safe working distance from energized equipment. De-energizing equipment is the most effective way to prevent arc flash incidents. However, this is not always possible. In some cases, it may be necessary to work on energized equipment. In these cases, it is essential to follow all safety precautions and to use appropriate personal protective equipment. Insulated tools and equipment can help to prevent electrical shock. These tools are designed to provide a barrier between the worker and energized conductors. Maintaining a safe working distance from energized equipment can help to reduce the risk of exposure to the thermal and blast effects of an arc flash. The safe working distance is determined by the voltage level of the equipment. It is important to remember that arc flash incidents can occur even when all safety precautions are followed. This is because arc flash is a complex phenomenon that is affected by many factors. However, by following all safety precautions, you can significantly reduce the risk of arc flash injuries and fatalities. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical safety professional before commencing any electrical work. It is important to consult the most recent edition of NFPA 70E for the latest requirements. The specific requirements for arc flash and shock protection can vary depending on the voltage, current, and other characteristics of the electrical system. The best way to ensure compliance is to consult with a qualified electrical safety professional.